Hello, welcome everyone. Welcome back to my channel. We were doing 10 questions to smash the grade, 10 questions to grade 9. And in that topic, we have already done quadratics and simultaneous equations. We have started indices and have done 5 questions in our part 1. And this is part 2 where we'll be doing questions from question number 6 to question number 10. But before that, I'm running GCSE classes at just £6 per hour, and you can enroll for crash course as well. Or if you're in year 10 and looking for like the GCSE preparation, the classes are starting from June for all the subjects, so you can just enroll yourself for it. And if you're looking for any grade, any subject from year 1 to A levels, just email us at exactacademy@gmail.com. And if you're looking for the free worksheets, and these all are present at www.exactacademy.com. So let me see the question number 6. It says a is equals to 3 to the power of n minus 1, b is equals to 3 to the power of 2n plus 1. Express the following in terms of a and b. 27 to the power of n. See, it has to be in terms of a and b only. So 27 to the power of n, let me try to just simplify a little bit. So 27 can be written as 3 to the power of 3. So 3 to the power of 3 whole to the power of n. Now the question is why I did so. Because whether it's A or B, they both are with the base number 3. So this is the reason I tried to simplify it in terms of 3, in the base of 3. So it will give you 3 to the power of 3 whole to the power of n. Power over another power, applying the power rule that we have already discussed earlier in the part 1. This is 3 to the power of 3n. Now you can see we have splitted this in the form of 3 to the power something. Now let me try to decipher what it could be. It could be 3 to the power of n minus 1, 3 to the power of 2n plus 1. Let me just try some combinations. Combinations like a times b, a by b, these kind of combinations. If I multiply a and b, a is 3 to the power of n minus 1 and b is 3 to the power of 2n plus 1. Having the same base number, if I'm multiplying, I have to add the powers. It will give you 3 to the power of 2n plus 3, 3n, and minus 1 plus 1, 0. Okay, yeah. That means it's a, b. We got it. So in terms of that, it's actually 3 to the power of n minus 1 times 3 to the power of 2n plus 1, which is AB. So answer is AB. It's a little bit tricky. Obviously, you just have to go for some combinations. Moving on to the next one, 1 over 3 to the power of n plus 2, which is already in a base number 3, so we don't have to simplify it further. But we have to look for some combinations. A times B already taken. Let's say A by B. So 3 to the power of n minus 1 over 3 to the power of 2n plus 1. Subtracting, because they have the same base number, you are dividing. So we just have to subtract the powers. So 3 to the power of n minus 1 minus 2n plus 1. 3 to the power of n minus 1 minus 2n minus 1. This will be 3 to the power of minus n minus 2. It is looking like exactly this, right? And this can be written as 3 to the power of negative n plus 2 or 1 over 3 to the power of n plus 2, which is this combination. Obviously, that means we can write this is actually n plus 2, which is nothing but 3 to the power of n minus 1 minus 2n plus 1. 3 to the power of n minus 1 over 3 to the power of 3n plus 1, which is A by B. See, when the questions are a little bit tricky, you have to do how I solved it. The first thing is try to split them into the form of a to the power of b, which is mentioned in the question. In this case, the base number is 3. So this is why for the part A and for the rest of the part, we'll try to decode, or we'll try to split in the form of 3 to the power of something. Second thing is, even still you're not clear what kind of combination it's having, so go for a times b, a by b, a squared, b squared. That kind of combinations are most common, and there are high chances to get the answers. Moving on to the part C, 1 over 27. Again, we just have to split in a form of 3 to the power of something, which is 1 over 3 to the power of 3. Now it doesn't have any n in it, and let me see in what case we can't have n. if I'll make 2n, see, now try to understand it. This will give you the idea. If it doesn't contain any n, that means n has been eliminated entirely, and that can be done if the coefficients are same. If we'll make the coefficient same, it would be easier for me. So that means the coefficient of this is 2n, this is n, so we just have to square it like this. In this way, I'll be able to make it 2n. So this will become 3n minus 1 whole squared. This will become 3 to the power of 2n minus 2. This is a squared. Now b is 3 to the power of 2n plus 1. If I'll subtract these two, there are high chances we can eliminate and can get the answer. Obviously, it will be eliminated, but there are high chances that we can reach to the answer. So for that, I just have to divide it. So when I divided 3 to the power of 2n minus 2 over b, which is 3 to the power of 2n plus 1, subtracting will give you 3 to the power of minus 3, which is 1 over 27. Yes, we got our answer. So it's basically a squared is 3 to the power of 2n minus 2, b is 3 to the power of 2n plus 1, and hence we just have to divide it. Will give you the answer. Moving on to the question number 7. M is a to the power of p and n is a to the power of q. M times n is a to the power of 4 and m squared n cubed is a to the power of 9. Find the value of p and q. So m is a to the power of p and n is a to the power of q and mn is a to the power of 4. See, what's given, it's actually two different equations are given and we are supposed to solve p and q. That means we have to do something that at the very end we'll get the simultaneous equations in terms of p and q. Then we can solve it. So m in place of, this is my first equation, so in place of m, I'll be writing a to the power of p and n, I'll be writing a to the power of q. This will give me a to the power of 4. So having the same base number, I'll add the power. So p plus q is equals to a to the power of 4. Now on comparing, because they both have the same base number, so I can just compare the powers. So which is p plus q equals 4. That's my first equation. Moving on to the second one, m squared, which is a to the power of p whole squared, and n cubed is a to the power of q whole cubed, is equals to a to the power of n. This can be written as a to the power of 2p times a to the power of 3q is equals to a to the power of n. Again, we are multiplying, having the same base number, I have to add the powers. So it will be a to the power of 2p plus 3q is equal to a to the power of n, and I'll get my second equation as 2p plus 3q equals 9. Now either go for elimination or substitution, anything will work. I'm just opting for elimination method, which is p plus q equals 4 and 2p plus 3q equals 9, and I just need to make the coefficient of any variable same. Let me make p the same. For that, I'm multiplying it with 2, 2 and 2, which will give me 2p plus 2q equals 8, 2p plus 3q equals 9, subtracting. I have already discussed in my part day 2 in which I have discussed the 10 questions on simultaneous equation, when to subtract and when to add the equations. 2p minus p, 2p is 0, 2q minus 3q is negative q, and this is negative 1, so q is 1. Put it in either of the equation. Let me put it here. I can directly say p is 3. And these are the values of p and q. Moving on to the question number 8. 5 to the power of x plus 1 over 3 is equals to 25 to the power of 1 over x minus 1. Find the value or values of x. This is actually x minus 1. It should be inside the bracket. So 5 to the power of x plus 1 over 3 is equals to 5 to the power of 3 because I always say that, like from the beginning you have seen, I'm saying that if one is in its simplest form, 5 to the power of something, and another on right hand side or in division, just try to convert them into the form of like which has a base number, a prime number. 5 is a prime number, 125 is not a prime number. So obviously I'll try to change 125 in a form of 5 to the power of something. So 25 can be written as 5 cubed, and this is whole to the power of 1 over x minus 1. So this can be written as 5 to the power of x plus 1 over 3 is equals to 5 to the power of 3 over x minus 1. We are just multiplying the powers together because of power rule. We have made the base number same. I can just equate the powers. I can just compare the powers. So x plus 1 over 3 equals 3 over x minus 1. Cross multiplying, I'll get x plus 1 times x minus 1 equals 3 times 3, 9. So x plus 1 times x minus 1, either factorize them conventionally, or there's a direct rule which says a plus b times a minus b is always a squared minus b squared, which is x squared minus 1 squared equals 9. X squared is 10 and x is plus minus root of 10. So this is the solution for part A. Now for part B, it says find the value of a to the power of m plus b to the power of n times a to the power of 2m minus b to the power of n. This is the conventional factorization. That means multiply first term by first term, a to the power of m times a to the power of 2m, multiplying first term by second term minus a to the power of m b to the power of n. Now multiply second term and first term plus b to the power of n a to the power of 2m, and multiplying this and this, so minus b to the power of n times b to the power of n. So here same base number, different powers, add the powers. A to the power of 3m. Now these two are entirely different base number, powers O are different, or I can just take out b to the power of n as common. So plus b to the power of n will give you a to the power of 2m minus a to the power of m. And this is same base number, even the powers are same, so 2m. Well, this will be a final solution. You can't do anything further. Now question 9 says find the value of m if 3 to the power of m minus 3 to the power of 1 minus m plus 1 equals 0. Now see this one. It's looking a very weird kind of equation, but if you try to simplify it, whenever you see such thing, always try, if you have 3 to the power of 1 minus m, try to split it. 1 minus m, that means this can be written as 3 to the power of, let me just write it, we can write it 3 to the power of m minus 3 to the power of 1 times 3 to the power of minus m. Obviously 1 minus m can be written as 3 to the power of 1 times 3 to the power of minus m, and this will be plus 1 equals 0. Now there is a negative power. Always if there is a negative power given, you have to make it positive, and how you can do it, as 3 to the power of m minus 3 to the power of 1, which is 3 over 3 to the power of m plus 1 equals 0. Obviously we have to remove the denominator. Okay, sorry, into 4 is already here. So I can write 3 to the power of m minus 12 over 3 to the power of m plus 1. If something is in denominator, you have equation, we always try to get rid of this, and that's why I need to multiply whatever there is in denominator with every term. So it will give you 3 to the power of m whole squared minus 12 plus 3 to the power of m. Now it's taking a shape. So it's looking like quadratic, obviously. So what I can do, I can just assume 3 to the power of m as x. When I'll do so, this will become x squared minus 12 plus x equals 0. Or x squared plus x minus 12 equals 0. Okay, it's a quadratic, very simple. The factors are positive 4 and negative 3. So x plus 4 times x minus 3. So x1 is negative 4 and x2 is positive 3. Putting that value, we have assumed x as 3 to the power of m. So 3 to the power of m as 4, negative 4, and 3 to the power of m as positive 3. Anything to the power of something and cannot make it negative, obviously. So this is not possible. Only the possibility is this equation with this, which is 3 to the power of m is equals to 3. So I can write 3 to the power of m equals 3 to the power of 1. We have made the base number same, m is 1. So that's the value of m. Moving on to the last question. Population of a frogs in an area is 200. Their population increased by 10% every year. And okay, the population increases by 10% every year. Then write an equation that models the population of frog in any year basically. So initial population of the frogs are 200. And the population increases by 10%. That means the next year it will be 1.1. Obviously, that means why I did 1.1? Because it will be 100 plus 10 by 10. Or if you don't know, conventional way is 200 and it increases by 10%. That means I have to calculate 10%. So times 10 by 100. But it increases, that means we have to add it to the initial amount, which was 200. So increasing by 10%, that means 10% of 200 added to 200. So taking out as common, this will give me 1 plus 10 over 100, which is 1.1. So this is why I have directly written, and once you start doing some questions, you can write that directly. So 200 and increased by 10%, that means times 1.1. Next year again, this is for the first year, originally it was 200. So next year was this one. Then next to next year, again 10% of this will increase, which means now this is our initial amount and 1.1 of this will increase. So it will become 1.1 whole to the power of 2. Then for the next year, it will become to the power of 3, then 4. So at any time, I can say my equation be population at any n year is 200 times 1.1 whole to the power of n. Now find the population after 5 years. So only for 5th year, I just need to put 1.1 to the power of m, which is 5 in this case, which will give you answer as 200 times 1.61051, and which will give you approximate like 322.10. So obviously approximately 322 frogs. That will be the population after 5 years. So that's it for today. These were the 10 questions on indices, and definitely these are enough to upgrade your grades. And even if you're aware of this topic, it will be more than enough to give you idea, and you'll be able to produce the questions there in the exam. So what I suggest, even if you think you're running out of time, you don't have to practice too many questions. My suggestion is go through this, but never do the mathematics by looking into the question. Okay, this is okay, I'm done, I'll directly go and do in the exam. Maths won't work like that. Even to be honest, as a maths teacher, I would never suggest you to go by end time and do this. But even if you have reached to that point that you haven't done too many, maybe there could be many reasons, but with any reason, if you're not able to work properly with your mathematics this year, so this is the best way what I'm doing. But even in that, I would suggest you, once you are done with this question, first thing is, when you start the video, try to do question on your own. If you aren't aware of the topic, you are clueless, just go through the question, understand it, and then try the questions on your own. When you start, mathematics is like this. You see, you think, okay, I can do this. This is very simple, and I'll do that in exam. And when you will be in exam, you will stuck, right? This is the trick of the maths. It seems you can do, but unless you won't practice, you won't be able to do it. So after going through the videos, you have to try it on your own. So I'm not asking you to grab the book and do as many questions as possible as you're running out of time. I'm talking about these 10 questions. Practice these 10 questions 2 or 3 times unless you become pro. So I would suggesting go through the videos, then try to do question one time, then try to do question one more time and make a short note. So this is my suggestion, and definitely it will work. So that's it for today, guys. Bye everyone. Take care.